So this review is for pre-cal. It's just sort of an overview of the basic algebra skills that you need to brush up on before we can dive into this class. Feel free to watch the skills as often as you need. Dive back into your Math 3 notebooks, come see me for help. But these are all kind of skills that I sort of assume that you're good with. So the first topic we're going to talk about is factoring. You've learned GCF, greatest common factor. You've done that since Math 1. Number 2, the difference of squares. Number 3, the sum and difference of cubes. And then number 4, trinomials. I'm going to give you one example of each. Again, if that's not enough, feel free to come see me and I can give you more. Okay, so when you have to factor, it's not going to say how to factor. You just have to look at it and know if you're going to GCF, or if you're going to squares, or if you're going to do cubes, or if you're going to do a trinomial. Squares and cubes both have 2 terms. Trinomial obviously has 3 terms. GCF can have 2 terms. It can have 100 terms. But if they all have something in common, then you're going to take it out. So this is where I tell everybody to start. GCF always, if you can, and a 4x squared minus 49, there is no GCF. So we're done with him. I have 2 terms, so I can either do squares or cubes. Squares, you have to have 2 terms. It has to be subtraction, has to be. You cannot do the difference of squares if it's a plus sign. That's why it's called the difference of 2 squares. It has to be the difference. Your numbers have to be squares. 1, 4, 9, 16, 25. You should be familiar with those numbers. And your powers, your exponents have to be even. So like x to the 6th is a square because it's x to the 3rd times x to the 3rd. X to the 10th is a square because it's x to the 5th times x to the 5th. X to the 9th is not a square because your power is not even. So make sure you know the difference between the numbers being squares and the powers being squares. The powers just need to be even. Okay, then to factor squares is really easy. You have 2 parentheses. Oh, and I have squares because 4 and 49 are both squares. So what makes 4 a square? Well, it's 2 and 2. X squared, when I cut that in half, that would be x and x. If it was x to the 6th, it would be x to the 3rd and x to the 3rd. 49 is 7 times 7. And for squares, you always have 1 plus and 1 minus. The reason you have that is because when you multiply this back out, you need those middle 2 terms to cancel each other out because you don't have a middle term here. You only have 2 terms. So if I were to lobster or to multiply this back out, 2x times 2x is 4x squared. 2x times negative 7, positive 7 times 2x, and a positive 7 times a negative 7. So you can see what I mean about those 2 terms canceling each other out. That's why when you do squares, it has to be 1 plus, 1 minus. So then this is your answer. Okay, this one is 6x squared plus x minus 12. First, again, we're going to look for GCF, and there isn't any. 3 terms, it's got to be a trinomial. Trinomial is where you try to put things in the parentheses so that when you lobster or multiply it back out, you're going to get the original problem. With 6, I can go 6 and 1 or 3 and 2. I always start with the 2 factors that are closest together. And you can see how 2 and 3 are closer together on a number line than 1 and 6. 1 and 6 are farther apart. So I'm going to start here. It's not guaranteed to work, but about 80% of the time it's going to be those 2. So I'm going to go 2x and 3x. I could have done 3x and 2x. It doesn't matter. With 12, my options are 1 and 12, 2 and 6, and 3 and 4. Again, I'm going to start with the 2 that are closer together, so that's 3 and 4. I'm trying to subtract to get a 1. 3 and 4. So I need that and that. So let's see. Oh, 3 and 4, because that's going to give me 9x, and that's going to give me 8x, and those are going to subtract to give me 1. Now, I want to end up with a positive 1. So I want a positive 9 and a negative 8. So the negative needs to go back here with a 4 and the positive up there with a 3. Again, this should all 100% be a review. Okay, this one obviously does not have a GCF. It is 2 terms, so you could be tempted to do squares, but 8 is not a square, and your power is not even, and it's not a minus sign. So in no way, shape, or form is this a difference of 2 squares. This is cubes. Cubes, you got to have 2 terms. You can have a plus or a minus. Your numbers have to be cubes. And a lot of times people don't know that list like they know their squares, but you can always create it. 1 cubed, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 64, 125, and 216. That gets you up to 6. Those are the ones you should be really familiar with. To factor cubes, you're going to do a short parentheses and a long parentheses. You're going to have 2 terms in this one and 3 terms in this one. This is the pattern that everybody seems to forget. I think you just learned cubes in Math 3. So this one should be pretty fresh on your mind, but you've probably used it the least. Okay, so to factor cubes, what times what times what is going to give you x cubed? That's easy. That's just x. 8 is a cube because it's 2 times 2 times 2. Okay, so the first parentheses is pretty straightforward. The second parentheses has 3 spots. Okay, the first spot is this guy squared. The last spot is that guy squared. The middle spot are these 2 terms multiplied together. Okay, so I'm going to do that one more time without all the drawing so it can sink in. This spot is this spot squared. This spot is this spot squared. This spot are these 2 multiplied together. Okay, and then you should all remember SOAP. Same, opposite, always positive. Same as the original problem, opposite the original problem, and always positive. Now, side note, this now looks like a trinomial. The back end of a cube will never factor again. So it may look like a trinomial, but don't go spin your wheels messing with it because it will not factor again. Okay, and this one's got some meat on it. This one's only 2 terms. It's definitely a GCF. They have tons of stuff in common. I got a 24 and a 16. Now I could take a 2 out. The G in GCF stands for greatest, so you have to go big. In fact, you have to go as big as you possibly can. So I'm going to take an 8, and he has an a to the 3rd and a squared, so I can take an a squared. B to the 1, B to the 4th, so I can take 1. 5 and 3, so I can take 3. So that's the GCF, and now I have to write what I have left over. So what I'm going to do is divide this term right here by that, and then write what I have left over. So that would be a 3, an A, no B's, and a C squared. And now I'm going to take this one and divide it by that, and that's going to give me a 2, no A's, a B cubed, and no C's. To check yourself to see if you're right, you should be able to multiply this back through and get the original problem. Okay, power rules. You do this in Math 1. I think you mess with a little bit in Math 2. These are rules that you've learned, but you probably don't use that often, so we need to dust them off a little bit. The rules are if you multiply, you add your powers. If it's a power to a power, you multiply. Okay, so let that sink in. If you multiply, you add your powers. If it's a power to a power, you multiply. If you are dividing, you subtract. And it could go this way too. That does not give me x to the -1. You don't want negative powers in your final answer. It gives me an x left over, but he's on the bottom because that's where I had more to begin with. This one up here is on top because this is where I had more to begin with. Negative exponents get moved and become positive. And then anything to the 0 power is not 0, it's 1. Okay, so there are your rules. And again, that should 100% be a review. So if I come in here and clean this up, I'm going to clean this guy up first. That's a power to a power, so I'm going to multiply. So that would be x to the 6th and y to the 3rd, because that's a 1. And then I'm going to bring everything else down. Now I'm going to multiply the top. So that's going to give me 4x. When you multiply, you add your powers. So x to the 7th, y to the 4th, over 2x to the 4th, y to the 5th. And then I'm going to divide. Now, I'm not doing 4 minus 2. This is big old 4 and big old 2, and this is the divide symbol. So I'm dividing, and I'm going to get a 2, and it's going to go on top because that's where my bigger number was. If I had 2 over 4, then my 2 would be on the bottom because that's where my bigger number would be. X's, I'm going to subtract. I have 3 left on top, and Y's, I have 1 left on the bottom. Okay, this one, let's see, the negative is just chilling on the top. 3 and 27, I'm going to divide and get a 9 on the bottom because my 27 is bigger. X's, I'm going to subtract and get 3 on the bottom, and then this is negative, so he's moving down and becoming positive, and that's going to give me y to the 5th because now I'm multiplying, so I add my powers. I have an empty top, so I'll put a 1 up there to hold its spot. And again, if that's too fast, if you need to slow it down, then work it out, rewind, listen to it again. Okay, roots. In Math 1, when I teach roots, I talk about going hunting. So there are different kinds of roots. This is a square root. So we are hunting squares, kind of like when you have deer season. Technically, you're only supposed to be able to kill deer, not turkey. There's a turkey season. So this is square season. So the only numbers I'm looking for are squares. So please don't tell me that 20 is 2 times 10 because I can't shoot either one of those numbers. I can only shoot squares. So what your job is to go into 20 and find me a square. Remember, these are your squares that you should know. So the square that's in 20 is 4. So I'm going to go 4 times 5. I'm going to circle the 4 because that's what I'm going to shoot. Now when I shoot it, I'm square rooting it. Square root of 4 is 2. 2 comes out. I leave some room and put your 5 back up under there. So the 5 is like the turkey that you saw that you couldn't shoot. It has to stay in the woods. Okay, but this is the deer that I shot. Now, for your powers, some teachers make this really, really difficult. It's not. This is a square root. So technically, there's a little 2 right here. It's called its index, and it sits right there in that little nook. We don't ever write it because we do square roots so much. It's sort of like our default setting is a square root. But there is a 2 there. It's just never gets written. So guys, what you're going to do is you're going to take your powers, and you're going to divide it by your index. We're going to do one in a little bit that has an index that's not a 2, so you'll be able to see that. But here we go. I'm going to go 2 into 4. Well, that goes 2 times. So 2 come out with none left over. Okay, and I'm going to go again. 2 into 7. Well, 2 into 7 goes 3 times. Goes all the way up to 6. So there's 1 left over. Now I'm going to go 2 into 9. 2 into 9 goes 4 times with 1 left over. So take your index and divide it into your powers. Now again, I did not do that with my 20. My 20 I had to go square hunting. But my powers, I can just divide it by my index. Okay, so here's another one. Now this stuff sitting out here is just chilling. He's just hanging out. This is where we're hunting. So this is a square root because you don't see a number right here, so we assume it's a 2. And if you want to write a 2 there, that's fine. Okay, now 18. I don't care that 18 is 1 times 18 or 3 times 6. None of those are squares. I need a square. I need something I can shoot that's in an 18. And that's a 9. So I'm going to make him 9 times 2, and I'm going to circle the 9 because that's what I'm getting ready to shoot. What's the square root of 9? Well, that's a 3. So I'm taking a 3 out, but I already have a 2 out here. So you're going to multiply those two together. So now I have a 6. 2 is already here, and I brought a 3 out. And that's where the 6 came from. And I'm going to put my 2 that I didn't get to shoot back up under the root. If I don't do that, I'll forget him. And I don't want to miss a problem because I forgot something. I'll miss it because I don't understand what I'm doing, but I'm not going to miss it for a silly mistake. So I'm going to go ahead and put that 2 under there. All right, now you remember what to do with your powers. I'm going to take this 2 and I'm going to divide it into 3 and into 6 and into 1. So 2 goes into 3 one time. So 1 comes out. And there's 1 left over. 2 goes into 6 3 times. Oh, hold on, back up. I forgot about these guys that are out here. Okay, let's do this again. 2 goes into 3 one time. So 1A is coming out. There's already an A out here, so I'm going to multiply. And when you multiply, you add your powers. So there's an A squared out there because there was 1 already out there. Okay, now let's do the B's. 2 goes into 6 3 times. So I'm bringing a B cubed out. There's already a B squared out here. So I'm multiplying. And when you multiply, you add your powers. So that's B to the 5th. 2 does not go into 1. So he cannot come out. And there's your answer. Okay, so how is this one different? This is not a square root. This is not deer season. We are now turkey season. I can only shoot turkeys. So this is a cube root. So I'm hunting cubes. I don't care about squares. I don't care that 24 is 4 times 6. I can't shoot either one of those. I need cubes. Okay, well think about what your cubes were. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 is 125, and 6 is 216. Again, those are the cubes you need to know. So 8 goes into 24. Okay, now what's the cube root of 8? It's a 2. So 2 comes out, and 3 stays under. And I get a lot of questions right here is, what if I forget my little index, my 3? I'm not going to count off if you forget your index, but I don't want you to think that it's a square root and not a cube root. So I don't recommend getting in that habit. Keep up with your index. I'm going to do the powers the exact same way. 3 goes into 4 one time with 1 left over. 3 goes into 6 twice with none left over. 3 goes into 11 3 times all the way up to 9, so that leaves me 2 left over. Okay, so hopefully you're getting the hang of that, dusting off the couple of months from not having you done that. All right, now we're simplifying. A really, really common mistake is to come in here and say, oh, I can cancel the 4 and the 32, and that can be an 8. But you can't do that. When there are pluses and minuses involved, you can't do that. You're going to hear me say that they're married. If it has a plus or a minus, it's married, and it can only cancel with another married couple that looks exactly like them. You can't cancel parts that are married. And so that plus right there, that's your plus, saying that they're married. Okay, so what we're going to do is we're going to factor the top. It's a trinomial. Again, at this point in this class, factoring needs to be second nature, really quick. Factoring is now a part of the process. You learned that skill since Math 1, and so now here's where we use it. So I need this to be really, really sharp. 32, and I'm trying to get a 4, 8 and 4. I want a negative 4, so I need a negative 8 and a positive 4, and that'll give me a negative 32. And then looky there. There you go. Again, that should be complete review. Okay, now this guy, I don't know how to factor the top. So I can't factor and cancel. It's not a GCF, it's not squares or cubes, and it's not a trinomial. It has 4 terms. Okay, but you can do synthetic division. You can do synthetic division, or you could do long division if you wanted to. The reason I can do synthetic division, and we will review long division later, but I want you to remember synthetic division, when you don't have a coefficient right there or power on that x, you can do synthetic division. You're going to take the opposite of him and put him on a shelf, and then you're going to write all your coefficients in a row, and you have to watch out for holes. Like if it skips a term, you'd have to fill in a hole with a 0. And then you drop the first number always. And then you multiply, add, multiply, add, multiply, add. So 4 times 2 is 8. Add, that's 11. 4 times 11 is 44. Now I add. Well, I have to follow my sign rules. A negative 65 and a 44 is a negative 21. And then I multiply again. 4 times negative 21 is a negative 84, and that's a 0. Shelf off that last number. He's your remainder. And put your x's back in. This one's always going to be your constant. He's going to have your x. He's going to have your x squared. So 2x squared plus 11x minus 21. Again, that's all review. Okay, simplify. I see the division symbol right here, so I know I'm going to same change flip. People call that KFC, keep, flip, change. KFC makes me think of Kentucky Fried Chicken. I don't like Kentucky Fried Chicken. I like Bojangles. So I am going to always call it Bojangles. You're going to hear that for the entire year. So when I say Bojangles, I'm talking about keep, flip, change. Okay. While I keep, flip, change, while I Bojangles this, I'm going to factor. So the top right here, I'm going to GCF a 2. And then because I don't want to write this 1,000 times, I'm going to go ahead and factor that x squared minus 25. Those are squares. Okay. So then I'm going to erase him so I don't get confused. Over. All right, this is a trinomial. 15, that's 5 and 3. I want a positive 2. So positive 5, negative 3. All right, there's my keep. I'm going to change that to multiplication. I'm going to flip this guy and factor him. So I'm going to factor him on the top. That's a trinomial. Okay, now this one's a really good thing to factor to prove a point. Some people are going to say, okay, I'm trying to get a 5. Well, if I go 3 and 1, that's a 3x and that's a 2x. That gives me 5. And they'll throw some signs in here and think they're right. But here's the kicker. If you need a negative 3, don't your signs in here need to be different so that you multiply 3 times 1, you get a negative 3. Well, if I put a negative here and a positive here, that's going to give me a negative 3x and a positive 2x. That's not going to give me a negative 5x. So you have to really, really be careful about making sure that when you multiply this stuff back out, you're getting the original problem. So I'm going to go 3 and 1 because that's going to give me a 1x and a 6x. And I want him to be negative to give me the negative 5. There we go. So now that gives me a negative 5 in the middle and a negative 3 in the back. Up here, I'm going to GCF a 4x. And that's all I can do to him. Okay, so there's my keep, flip, change, and I factored as I went. And then this is the really fun part. You get to just cancel. Anything on the top that's the same as anything on the bottom, you can cancel. But remember, singles can cancel with singles. Married couples can only cancel with other married couples. Anything on the top can cancel with anything on the bottom. All right, those are all my married couples. But look, I've got this single and this single. They're not the same, but it's okay. They're single. So I can come in here and take the 2 and divide that, give me a 2, and I'm going to go and put my x down here so I don't lose him. So on top, I have an x minus 5 and a 2x plus 1. And on the bottom, I have a 2x and an x minus 10. Don't miss this because you do everything right, but you lose something when you go to write your final answer. You guys are strong in math and probably have always been strong in math and can do things really quick and really easy. And sometimes you can do a lot in your head. What you need to make sure in this class is that you slow your brain down enough to catch the details. Don't get the pre-cal part right, but mess up on an algebra mistake, because then your grade is not going to reflect your knowledge. So I need you to really, really love on some details. Okay, we're going to solve this. Not going all the way back to solving linear equations. That seems a little elementary at this stage. So we're just going to dive in and start solving some quadratics. There are a couple ways you can solve quadratics. You can factor and set it equal to 0 and solve. That's one method. You can complete the square. You can do roots. And you can quadratic formula. All of those you've learned in Math 2 and Math 3. I hear it all the time when I walk up and down the hallways. I know you've been taught this. You just have to dust off the months from not doing it. But this is not a skill that I'm going to teach you. You need to know how to do this. Okay? Factoring and solving, I think, is the simplest. So if it will factor and solve, that's the way we want to go. So let's check this one out. 10s, 1 and 10 and 2 and 5. I'm going 2 and 5. That's going to give me the 3. I want a negative 3, so a negative 5 and a positive 2. That still gives me my negative 10 in the back. Keep it set equal to 0, and you can do this part in your head. I'm just showing what you're doing. Set each one equal to 0 and solve it. So those are his two solutions. And I know I talked about this in class, but if he has a power of 2, he should have 2 solutions. If he has a power of 5, he should have 5 solutions. That power tells you how many solutions he should have. Okay, this one's fun and really easy, because this is the guy that makes you quadratic, and then if you'll see, that's a constant. So this is the roots that I was talking about. You can do this another way, but I'm going to show you the roots because it's the simplest. I'm going to keep my 3x squared. I'm going to add my 48 over. And then I'm going to divide by 3 to isolate my x squared. And then I'm just going to root both sides. Now here's where people miss it. This is why it's called roots, because you root both sides. Here's where people miss it. What did I say about powers? He has a power of 2. We'll only have one answer. So that breaks that rule. So if you give me this is not a partial credit kind of thing. This is you completely missed it, because this is one of those details. This is not a pre-calculus skill. This is an algebra skill that I need you to come to pre-calculus already knowing. To solve this, when you root both sides of an equation, you have to put plus or minus. Because if x squared equals 16, x could be a 4. 4 squared is 16. Or it could be a negative 4, because negative 4 squared is a positive 16. And that's why you have to have that plus or minus. Now please make sure you're super clear. If I give you the square root of 25, the answer is not plus or minus 5. The answer is just 5. The square root of 25 is 5. But remember, on this, you started with this thing. X squared equals 16. You put the square roots in here to solve it. When you do that, you must have the plus or minus. When you square root both sides, when you lay that down, you have to put the plus or minus. If the square root is there to start with, then you don't plus or minus. Okay? Okay, and then this one. Now this one looks like it wants to be roots. And I have some people who come in here and say, ooh, can I divide by x? You cannot, because if you do that, you're going to lose one of your answers. He is quadratic because he has the x squared, but this is different because this guy's not a constant, so it's not like the one we just did. What you need to do here is subtract the 5x over and get it equal to 0, and then you need to factor this. And it's really funny because a lot of kids right here get stuck on how to factor this, when this is just a very, very simple GCF. They both have an x in common. And then I set each one equal to 0 and solve it. And I get my 2 answers. Okay, so again, this was review. We're dusting off a couple months of not using it. But these are skills that I need you to have so that we can move forward. So make sure you're good with this. If you're not, come see me during Smart Breakfast and we can go over anything in particular that you need to go over. Thanks.